This short video will explain logical arguments and how to determine if they are valid or not. First of all, let's discuss what a logical argument is. An example is the following. If I'm a millionaire, then the sun is not blue. I am not a millionaire. Therefore, what? What exactly? That is the question. What conclusion makes sense here, given the premises? A common response to this is B, I'm a millionaire. But we'll get back to this in a minute. There are a few concepts that need reviewing first before we move on. First of all, what are conditional statements? Conditional statements are if-then statements that begin with a premise and finish with a conclusion. Next, we need to discuss tautologies. These are statements that are always true under any situation. Lastly, the make it false method. The make it false method is what we use to determine if a conditional statement is a tautology. Now, there are other methods that we can use for tautologies, but this is the best for conditional statements. Let's discuss the structure of an argument. Simply, it is a set of premises followed by a conclusion. You can have as many premises as you like, up to n, and then you're always followed by a conclusion. For our example from before, we have, if I'm a millionaire, then the sun is not blue is the first premise. I am not a millionaire is the second premise. Therefore, the sun is blue is the conclusion. Argument form is shown here and here, in that the premises are listed, then there is a line, and then the conclusion follows. Do not forget that in logic, all work must be shown using symbols. For example, I have chosen the variables m and s to represent the statements, and I have rewritten the logical argument using the logic symbols as seen here. Premise 1, premise 2, our dividing line, therefore symbol, and our conclusion, which is s in this case. This form is how arguments are presented, but is not the form we need for this method. For this method, we need to look at these a different way. For this method, we need to use the logical form. The logical form is as follows. You have all of the premises, each one connected with a conjunction or an and symbol. Now, this statement is a conditional. So here's the conditional symbol. And then lastly, we have the conclusion on the right. If you have a compound statement like the case here, you must divide them by parentheses so that we know which is the premise and then which is a conjunction, because you can have conjunctions within the premises. So what we have here is our example in logical form. Finally, let's discuss whether an argument is valid or not. That is the point of this lesson. This is not an evaluation of true or false. Rather, we are asking if the structure is logical. In regular English, what we want to find out is if the argument makes sense. Quite simply, if the logical form is a tautology, then the argument is valid. And if it is not a tautology, then it is not valid. Again, this is why I mentioned before that we need to review the make it false method, because this is how you prove whether or not conditional statements are tautologies. In logical form, if we can force the premise to be true and the conclusion false, then it is not valid. In every other case, it will be valid. Now remember, for conditionals, true then false is false. Every other case is true. Here is our example again, in logical form. Now let's see if it's a tautology or not. Again, we are employing the make it false method. We will always start on the right side because, as we know, it is simpler to make the right side be false first. So we'll move over here and set that to false. Next, we must number everything in order so that our teacher can follow the work. So that is our first action. Secondly, if S is false, then this is not S, and so that must be true. That will be our second action. Now, in order to make this be false, everything here has to be true, and then a false. So we will set this to be true. That'll be our third action. If we set this to be true, this is not M. That means that M must be false. Fourth action. Now, a false then anything and a false then true is going to be true. This is true. So what we have is a true and a true, which makes this be true. This will be our fifth action and our sixth action. And finally, what we have here is we have true, then false, which is indeed false. Because we came to a false conclusion here, this is not a tautology. Therefore, this argument is not valid. Now it's time to try it yourself. Read the following statement and pause this video and try to work out if this argument is valid or not. Remember, the steps are as follows. First, you must translate English into logic symbols. Then you must write it in logical form for arguments. Finally, you will use the make it false method, which you should know well by now, to determine if it is a tautology. Now pause the video and give it a try. Let's see how you've done. First of all, your argument and argument form should look something like this. You should have C conditional R, S conditional not R, S, the line, and therefore not C. Now, the structure will be the same here. If you chose different variables, that's fine, as long as you have a similar structure. Next, you should have this written in logical form so that you can solve it. You should also be using graph paper or something to keep it all lined up nicely so you can show your work. We will now check your answer, and I'll go through the steps to finding a solution to this problem. Starting on the right, we will set this to be false because we want this all to be true and this to be false. Setting not C to be false, and again, that's our first action. That means that this C will be true, second action, and this C will also be true, and that can be our third action. These can be switched, it doesn't matter, they're the same thing. Okay, we want all of these to be true. In order for this to be true, R cannot be false because true then false is false. So we will set R to be true. That will be our fourth action. That will make this conditional be true. That's our fifth action there. Now, we set R to be true. So this not R must be false. Since that is false, and that's our sixth action, this sets this to be false, and it is unavoidable. Since we have one false here, that sets everything false. Remember that it needs to be true, true, and true, but it's not. We have a false. Therefore, sorry, I'm a little late on this, but that'll be our seventh action. Finally, because of this, this must be true. It cannot be made false. Therefore, this is a tautology, and this is a valid statement. If you got it right, good job, and if not, try it again. Now remember, with the make it false method, you don't always have to follow the same way that I've done it. There are a few choices. In the end, though, for this case, you will always reach a tautology and a valid argument. I hope that you found this video valuable for figuring out what arguments are, and determining whether or not they are valid. Thanks for following along.